Hey, I'm Nico and I'm going to teach you about graphing sine and cosine graphs. Here we have the main formula for graphing sine equations. F of x equals d plus a sine bx minus c. The amplitude will be the absolute value of a, period 2 pi over b, horizontal shift c, and vertical shift d. Right here is a standard cosine equation and it's very similar to the sine because all these values stay the same. The standard form of the sine equation looks like this, where the amplitude is 1 and there's no vertical, horizontal, or period shifts. The standard form of the cosine equation is very similar to the sine, but instead has a maximum on the y-axis. The graph of cosine equations is the same as sine, except you'll be shifting from this point here instead. Example 1 is how you would go about graphing a sine graph with a period shift. Refer back to the main tools we saw in the box at the top, right here, and notice that b in this equation is 2. This means that if we plug 2 into the equation 2 pi over b, we would get pi as our answer. And this also means that the wavelength of the graph will end pi units away from the last on the x-axis. Graphing with an amplitude change is much simpler because all that changes is the height of the wave. In this example, the maximum becomes positive 3 and the minimum becomes negative 3. You need to watch the sign of the value c when graphing a horizontal shift. We can see here that the graph will shift to the right by a value of pi over 3, but in the equation it's negative. This is because in the main formula c is negative, so you take the opposite of what you see in the function given. The best way to draw this is to start with the standard form right here, the gray line, and redraw moving to the right, pi over 3, the blue line right here. A vertical shift will just shift upward if the value d is positive, or downward if negative. Pretty simple right there, right here. Now, you can start on practice problem 1 and I'll pause the video. Okay, now that you're done with practice problem 1, let's go over this. The best way to start is to record your values. The amplitude is 2 because the coefficient in front of the cosine is 2. The vertical and horizontal shift are zeros because there are no values given to us. And the period is pi over 2 because if you do 2 pi over 4, that becomes pi over 2. Now, about graphing it. You start by putting the maximum value at 0, 2, because that is the maximum because the amplitude says so. And now you move to the right, pi over 4, and put another maximum there because it's a cosine graph. In the middle of these, at pi over 8, negative 2, right about here, you put a point here, and that'll become your minimum because that's 2 below and halfway between. Now, once you draw a line through all that, you'll have your one wavelength, and you do that same thing on the left side, and you'll have another. And I just kept going on each side because why not? Alright, now start practice problem number 2, and I'll pause the video. Now that you're done with practice problem number 2, we can start graphing this one. First, we see the amplitude is 3 because it's 3 sine. We can see the period is pi because if you use the equation 2 pi over b, where b is 2, you get 2 pi over 2, and if you simplify that, it becomes just pi. The vertical shift is 2 because 2 is being added to the entire system here, and the horizontal shift is 0 because there's no number inside the parentheses other than 2x. Now when you're graphing this, you can start at this point here because you moved up 2. Now it looks like 1 here because I made this axis go up by 2's because I couldn't fit 5 all the way up to the top. So you go up 2 here, and then you see that your ending of this wave is right here. So you draw a point there. Now you add your maximum, which would be pi over 4, comma 5 right here, and then your minimum, 3 pi over 4, comma negative 1 right here. And then you connect these dots, and then you have yourself a wave. And then you do the same thing on the negative side, and you'll get another one. And you could keep going on and on forever if you wanted to. Now, thanks for listening, and start on the quiz.